Hello, and welcome to the first installment of CYBR in 10. My name is Nick Dulovitz. I'm the Director of Technical Alliances at CyberArk. CYBR in 10 is a video series consisting of 10 to 15-minute installments, with each video covering a single topic, with the common theme being education around CyberArk specifically and privileged best practices generally. Today, I'm going to talk about the 7 steps to the Privileged Account Security Hygiene Program. In general, the hygiene program is a group of risks and overall understanding around the details specific to those risks. Most importantly, we need to understand what can be done to mitigate these risks. How a customer will mitigate those risks is up to them. However, it's our job to be able to provide the guidance to the client on how to mitigate, or better yet, almost eliminate the risk. So, let's touch on the 7 main points of the hygiene program. Step 1, focus on eliminating irreversible network takeover attacks, e.g. golden ticket. Step 2, control and secure infrastructure backdoor accounts. Step 3, limit lateral movement. Step 4, protect third-party privileged accounts. Step 5, manage SSH keys on critical UNIX servers. Step 6, defend cloud and DevOps backdoors. And Step 7, secure shared IDs for business users, integrating and accelerating adoption of multi-factor authentication. So let's get started with Step 1, irreversible network takeover attacks. So from an attacker's perspective, it's all about establishing persistence. Being able to hop back onto a network, no matter what defense tactics the adversary attempts, is critical. In an organization with no controls, you may see limited use or the complete absence of multi-factor authentication. This allows compromised credentials to be used just as easily as legitimate credentials. Organizations need to strongly tie trusted identities to accounts. So additionally, you'll notice how privileged credentials are being used. With no phase 1 hygiene, you'll see privileged credential hashes for tier 0 systems found on tier 1 and 2 systems. What does that mean exactly? Well, tier 0 systems are the critical infrastructure. Active Directory domain controllers are certainly critical infrastructure, but you could also include DNS systems, SAN storage, or virtualization infrastructure. Really, a general rule of thumb is that anything that correlates to the first phase of a company's disaster recovery program aligns to your tier 0. Tier 1 is more your standard application servers, your web servers, application servers, database servers, and so on. These are important systems, but not critical infrastructure. Lastly, you have your tier 2 zone. This is where the end user resides. So desktops, laptops, tablets, IoT devices, mobile phones, all of those types of things are tier 2 type assets. So what we often find is that system administrators and other privileged users are using tier 0 credentials on tier 1 and 2 systems. This allows a malicious actor to not only laterally move horizontally across the tiered zone, but also pivot upwards into the critical infrastructure zone. Not a good thing. So how do we go about getting to the desired state? Well, it's quite easy, actually. We want to get to a state where all access to tier 0 is completely segmented off and isolated. Additionally, you must have multi-factor authentication set up to truly tie the identities to the account being used. Also, we need to have an architecture that's built around not leaving any privilege hashes left for a bad actor to acquire. We must make sure that as soon as a privileged credential is used, it doesn't leave a hash on a lesser tier device. Or, as soon as it's no longer being used, the credential is rotated, leaving the residual hash useless. Right? Additionally, we need to be able to monitor the network in such a way that we see indicators of compromise. We need to be able to detect when a rogue domain controller sync is being initiated, or someone is attempting to use a forged KBR TGT ticket. Lastly, we need to make sure that the creation of any unapproved credentials is blocked. All access in and out of our most critical zone is brokered through a secure privileged account security solution. So how do we get to this level of maturity? Well, in order to get to this desired state, we must first configure CyberArk to leverage multi-factor authentication. Regardless of what the backend technology is, Radius, SAML, PKI, right? We don't care, but multi-factor authentication is critical and must be set up initially. Secondly, we need to complete the no-hash architecture by properly protecting Tier 0 and Tier 1 assets with Privileged Session Manager. Privileged Session Manager is critical in keeping privileged hashes off the end-user machines. Lastly, leveraging privileged threat analytics and endpoint privilege manager give an organization the ability to actively protect and detect endpoints from potential compromise and malicious behavior. So moving forward, to phase two, control and secure infrastructure and endpoint backdoor accounts. It's common practice in IT to provide a single credential for multiple systems. This allows for easy administration, but equally easily lateral movement for an attacker. We need to break this habit, but still provide ease of use to the end user. What we often see in many organizations is that built-in accounts with the most power are seldom used. This is because they often have more privilege than the typical user needs. But also, there's no accountability. Without some sort of solution, there's no way to tell user A used account B. This rings true with Windows systems, Linux and Unix systems, databases, and network infrastructure, and additionally, cloud systems as well, right, across the board. So something that rings true with operation folks is the concept of the gold image. This is a base build of a system that is used to provision other systems. If the credential is password 1 on the gold image, there's a pretty good chance the password on all subsequent systems is also going to be password 1. What we advocate from a hygiene program perspective is that we work with the client to understand their environment and identify what assets to prioritize over others. For example, it doesn't make much sense to focus on onboarding a handful of Oracle databases when a client may have 10,000 workstations with the same password. Potentially, one phishing email successfully gets through, and at that point, it's game over for that particular client. So what we want to get to is a desired state to which an attacker cannot use these built-in credentials to move laterally or access resources of another system. It's a fairly simple to accomplish. We need to have three main components to locking them. We need three main components in place to locking these down. 1, unique. This prevents the lateral movement. 2, complex. This makes brute forcing a credential extremely difficult. And lastly, frequently changing. This really makes brute forcing nearly impossible. For example, if it takes a month of nonstop brute forcing a privileged hash, quite often that's perfectly fine. If the password is set to change every week, well, that password has been changed 4 times now, and whatever the correct password is, it's worthless. So in order to get to this desired state, we need to vault all backdoor accounts. We want to rotate these credentials periodically and after every use. And this is done completely within the context of the enterprise password vault. Phase 3, limiting lateral movement. One of the first phases of an active attack upon an organization is getting a foothold within the organization. Once an attacker has compromised the host, they can begin reconnaissance, expand their sphere of privilege, and further the attack. We need to be able to stop that initial foothold into the organization. What I more often see in many organizations is a complete lack of least privilege. The ability to do exactly what you need to do, no more, no less. This means removing the local administrator privilege for end users. Many organizations simply give end users full admin rights on their machines simply because it's easier and less hassle from an operations perspective. This is terrible practice because it allows any device to be compromised. Some organizations believe it's just too difficult to remove admin rights from users. Often users will insist they need admin rights to run certain applications and thus get full admin privileges. This is a fallacy. We don't have to give users administrative rights. We want to get to a state where users are no longer local administrators on their machine. Applications that need access are granted admin rights. Additionally, we can restrict users one step further. Even though someone may have access to run applications, perhaps they shouldn't. This is where application control comes into play. Being able to not only restrict local administrator access, but also restrict what applications a user can run is a very powerful tool in preventing the initial foothold of a malicious actor. Step 4. Protecting third-party privileged application accounts. Security solutions such as asset management and vulnerability scanners are valuable tools in providing security to an organization. However, incorrectly used, they can actually provide more risk to an organization. In order to perform an authenticated scan, one must provide a privileged account to one of these third-party tools. That tool then sprays that privileged hash to any device it scans. Worse yet, these tools themselves now become the targets of attackers as well. So how does CyberArk address this? Well, the first thing that we need to understand is the architecture leveraged by that third-party tool. Understanding that architecture will help us to determine what the appropriate flavor of CyberArk's Application Identity Manager, our secure API to the vault, should be applied for that particular tool. This API to the vault will then allow us to remove that hard-coded credential from the scanning utility and instead replace it with a dynamic call to CyberArk anytime that application needs to perform its scan. In addition to removing the requirement for the tool to host or to store the privileged credential, CyberArk is also able to rotate the credential after the scan has been completed, therefore invalidating any of the hashes that have been left throughout the environment due to that scan. This is supported via CyberArk's C-Cubed Alliance. We'll cover the C-Cubed Alliance in greater detail in a future video. Suffice it to say that by working closely together with other vendors that our customers are leveraging, we're able to provide a more secure solution or grouping of solutions for our customers to take advantage of, therefore getting additional functionality out of both or at times multiple solutions within their environment. Step 5, managing SSH keys on critical Linux and UNIX systems. SSH keys are often neglected in enterprise IT environments. In fact, they're just like any other credential. They need to be managed as such. What we see in many organizations is that SSH keys are being used and either they have no idea how and where they're being used, or worse yet, they don't believe they're being used at all. This is where CyberArk's DNA solution comes into play. DNA is able to scan a customer's environment to find SSH key trusts. So it's going to find the private and the public SSH key pairs. And then right from DNA, we can import those discovered keys into CyberArk. And just like with the username and password, where we would implement rules around who can leverage, who can access that particular credential, introduce auditing around the usage of the credential, and then, of course, manage the credential. So rotate it, right? Generate a new password value and set that password value on the target. We're able to do all of those same things with SSH keys. We're able to define who should be able to access those SSH keys. We're able to introduce auditing around the usage of those keys. And then, of course, we're able to manage those keys and generate a new key pair, updating the public key wherever that target relationship exists, and storing the new private key in the CyberArk Digital Vault. Next up, defending cloud and DevOps backdoors. Attackers realize that you don't have to attack the corporate office or data center to completely own an organization. Attacks on the cloud and on the DevOps solutions themselves offer an attractive attack vector. Compromising API keys or harvesting the embedded code in continuous integration and continuous delivery or CI/CD tools is becoming a very popular attack vector. Typically, we're seeing many organizations are in a state just waiting to be breached. Their cloud platform root keys, such as AWS, aren't being vaulted and just sitting on someone's desktop. Tools like Ansible and Jenkins are also storing privileged credentials in clear text just waiting to be stolen. We need to get clients to a state where this isn't happening. We need to vault AWS root keys and automatically rotate them just like any other credential. Additionally, those CI/CD tools are vaulted and secured as well. These credentials are retrieved on the fly and automatically rotated. The best methodology is to use CyberArk's Enterprise Password Vault to manage the cloud platform root keys, using CyberArk's Application Identity Manager and Conjure to address embedded credentials and secrets in the CI/CD tools themselves is also a necessary phase of this hygiene program. And step 7, shared IDs outside of IT. So at this point, I feel you have a fairly mature privileged account security plan. It's time to start thinking outside of the box. Let's face it, it's not just IT who use credentials. Business units such as marketing, legal, HR, and payroll all use shared credentials. And sadly, they often don't have the tools at their disposal like the folks in IT do. I've personally seen this. Marketing has a single account for their social media platforms, or HR shares a Workday or Bamboo HR account. this password is shared by all the people in that group, and because it's shared, the use of multi-factor authentication tools really can't be leveraged. That account may be stolen by a malicious actor or disappear when someone leaves the organization. The point here is that we need to extend privileged account security beyond just IT. So in a desired state, we want all shared IDs isolated and leveraging multi-factor authentication. We can do this when brokering access to the shared credentials through Enterprise Password Vault. Additionally, by using CyberArk's Privilege Session Manager to broker the connection, the end users can access the privileged account without ever knowing the password. So there you have it, the 7 steps of privileged account security hygiene. But